Hey, welcome back to Skur's Academy. Today we're going to try and answer the inquiry question of how can we explain an elementary understanding of the physics behind various light phenomena? Now, firstly, what is light? Well, light is the perceived electromagnetic radiation that we view in all forms of colors. Visible light is in between the wavelength distance of 380 nanometers and 700 nanometers. As light leaves the sun and eventually reaches the atmosphere of Earth, it is scattered by molecules in the atmosphere as it goes from the vacuum of space into the gaseous atmosphere, and the light changes what is known as mediums. We see that blue light has a shorter wavelength of about 450 to 495 nanometers. This shorter wavelength means that the light scatters easily in the atmosphere. This is called Rayleigh scattering, making the sky appear blue. Moving on to refraction. Refraction is redirection or bending of a wave as it passes through a medium. This can be caused by a change in the wave's speed or by a change in the medium. In this photo, we see a pencil appearing as it is bent in a beaker of water. This happens because light simply takes longer to reach point B in water, and that causes the light to bend when it goes from water to air, or vice versa. The angle that the light bends depends on the density of the water and the angle of incidence, as seen in this graph. The incidence ray hits the boundary and the normal, and is refracted as it crosses the medium from air into water. This is calculated using Snell's law, which is calculated using n1 over n2 equals sine theta 2 over sine theta 1. We can see in this diagram of a pencil in a clear glass container, the light leaves position X and is refracted as the medium shifts from water to air. The refracted angle of Y is then observed, showing a false perception of where the pencil is really located. Finally, total internal reflection. Have you ever dived into a pool only to look up and have a tiny window to the outside world, and everything around it looked like a silverish mirror back into the water, and wondered why this was? This is known as total internal reflection, a phenomenon which is essentially the opposite of refraction. Total internal reflection is the light instead being reflected back into the medium of water, rather than refracting out into the less dense medium of air. As light moves closer to what is known as the critical angle, denoted by theta c, the angle of refraction approaches 90 degrees. This is known as the critical angle, as no light is refracted out of the boundary or is reflected back into the medium. Thanks again for watching Skur's Academy. Hopefully that has increased your understanding of the various light phenomena we observe in our world.